Alright, so let's get on to proving the general formula using first principle. Right, so we said in doing that, since we are using first principle, we follow the 4 steps, right? Number one, we create 2 equations, right? Number one equation, which was this, is that y is equal to x raised to power n. And so our equation 2, this is giving us our equation 1. Our equation 2 becomes y plus what? Y plus delta y, which is equal to what? X plus delta x all raised to power n, because this is y and this is n. We are replacing it. I've taught this previous videos, right? That's number one. And step 2 says we subtract equation 2 from equation 1. So how do we subtract? All of this we subtract y. So step 2 we have y plus delta y minus y is equal to what? This, which is our equation 2, x plus delta x all raised to the power of n minus what? X raised to the power of n. Right? That's what we said. And so y will take off y. We're left with what? Delta y, which is equal to what? X raised to x plus delta x raised to power n minus what? X raised to power n. So what do? We said, I haven't done that. We try and expand. We will expand this guy, like as I've told you in other one. We expand this guy using binomial theorem principle. That's the only way to expand this, right? So we can come and say expanding x plus delta x raised to power n using what? Binomial theorem, right? Binomial theorem. What do we get? We're going to have, I've taught you what to do. I said for that, since we are dealing with x plus delta x, we're trying to expand. We start by saying n combination 0, and then we have x raised to power n minus 0, and then delta x raised to power 0. Alright, plus what? What's the second one? This is our first. Our second one becomes what? N combination 1, then we have x raised to power what? N raised to n minus 1, and then what? Delta x raised to the power of 1. Right? And then we move next to what? We move next to n combination 2, and then xn minus 2, right? And then we have delta x raised to power 2, plus so on and so forth. We don't want to continue from here because it's infinite because of the n. N is not a definite value. So how do we expand this further? By expanding this, we have our n factorial, what? N minus 0 factorial, 0 factorial, right? And then we have our x, n minus 0. N minus 0 gives us 0, or n, sorry, n minus 0 gives us n. And then our delta x, which is changing x raised to power 0. Anything raised to power 0 is what? Is 0. So that one is gone. That's for the first. And then for the second, which is this, is what? Is n factorial, n minus 1 factorial, and then 1 factorial. Right? We talked about this. And then we have x, right? X raised to power n minus 1, and then our delta x, or changing x raised to power 1. Plus, let's continue with that. We have n factorial, n minus 2 factorial, 2 factorial. Right? Then we have xn minus 2 and changing x raised to power 2, and so on and so forth. Let's try and break this down. In breaking it down, we're left with what? We're left with n factorial over what? N factorial, because n minus 0 is n. So n factorial is gone. Right? If we do that, we'll be left with what? Right, so if they cancel out, we'll be left. So if they cancel out, we'll be left with what? X raised to power n. That means these guys are gone by cancelling, right? So we're left with n raised to power x raised to power n. We have plus what? By this, what do? We can expand this. We can change. If we have n factorial and n minus 1 factorial, we can expand this down by saying n bracket n minus 1 factorial over n minus 1 factorial. Should in case this is 3, right, we can continue by saying the factorial continues n minus 2 and n minus 3 factorial, so that this can take off this. right? That's how it works. So, but because we are dealing with just n minus 1, because we have n factorial and n minus 1 factorial, it's going to be n bracket n minus 1 factorial over n minus 1 factorial. Now you can just check out the video link on, I'll leave the video in the description for combination and permutation as factorial. Right, so we're left with that. Alright, so what do? We're left with n. So if we expand this, we're going to have if we expand this guy, we're going to have n bracket n minus 1 factorial over n minus 1 factorial. Right, x n minus 1, then we have delta x raised to the power 1, the same thing, right? And let me just try and bracket it, that we don't have glitches. And then for this we have n bracket n minus 1 n minus 2 factorial over what? 2 factorial of what? N minus 2 factorial. You know what that means? They'll cancel out. Just trying to give it space. Right? We're not done, sorry. And then we have x of what? N minus 2 and changing x raised to the power 2. Let's try and cancel out now. This will take out this, and this will take out this. What are we left with? By that, expanding that, we're left with what? X raised to the power n plus what? N x n minus 1 changing x, right? Plus what? And we're left with n bracket n minus 1 over 2 factorial, which is 2. 2 times 1 is 2. X of what? N minus 2 changing x2, right? Plus so on and so forth, because it continues. Right, so this is the expanded form for this guy using binomial. So if we use binomial theorem, we are going to get, by using binomial theorem, by expanding using binomial theorem, this gives us what? X raised to the power n plus what? N x n minus 1 changing x, right? But it's not enough. I'll just try and see how we can manage. Right, so okay, let's put it here. Let's put it here. By using binomial theorem to expand, by expanding that, we got our answer as x raised to the power n. Just put something like this: x raised to the power n plus what? N x n minus 1 changing x plus what? N bracket n minus 1 over 2, right? And then we have xn minus 2, right? And then we have changing x. So that's the expanded form, right? If we expand it using binomial theorem, this is what we are going to get. Right? So I've taught you how to expand it. I'm just going to be wiping off this part so that we can continue from where we stop. Right? So expanding. Right, so I've taken that part off. We now know that if we expand this using binomial theorem, this is what we're going to get as our answer. And I've taught you that in the previous video, right? So let's continue from here. So we have x raised to the power y, that's delta x. We have changing x equal to this one, right? This guy, and the expanded form. Okay, let's just put it down. X plus changing x raised to the power n minus x raised to the power 1. So by expanding that, we got that. So that is what we expanded. So we're left with what? Changing y equal to what? This, the expanded form of this is x raised to the power n plus nx n minus 1 changing x, right? Plus n bracket n minus 1 over 2 x of what? N minus 2 changing x squared. That's the expanded form of this guy, right? So I'll just bracket it down. Now we've expanded this, but we have minus x raised to the power n minus n, right? So having done that, it's not hard. I can just simply take this one off, right? So we know what we're dealing with, right? So having done this, what next? You see that x raised to the power n will be minus x raised to the power n here, so they will cancel out. This will take out. So what do we do next? It's going to be x raised to the power y is equal to equal to nx n minus 1 brackets changing x plus what? N bracket n minus 1 over 2 x n minus 2 bracket changing x all squared. Now we're done with step 2. Step 3 said divide both sides by dx. So we're dividing both sides by changing x. That's this one. We divide this guy by changing x, and divide what? This guy by changing x. Next, to cancel out, right? You see that dx, we take out the x here, and then dx, we take out 1 from here. We're left with 1. Haven't done that. What we left with? We're left with what? Change in y over change in x is equal to what? Nx n minus 1 plus what? N bracket n minus 1 over 2 of n minus 2 bracket what? Change in x. That's what we're left with. So what do? We invoke the limit form, right? We're going to say we limit our dx, which is our what? Our step 4, bringing the limit out to what? To 0 of what? Of change in y over change in x, which is dy over dx. Right, sorry about the space. If we do that, our dy over dx is going to be what? It's going to be nx n minus 1 plus what? That is the first one, right? Plus what? Plus n bracket n minus 1 over 2 of what? X n minus 2 bracket what? This is 0, because we said this is going to 0. So what does that mean? Look at what it means. It means that 0 times everything here, this second one, 0 times everything here will give us 0. All these are gone. What are we left with? We're left with this guy. So what do we manage now? Can we use somewhere else? Our dy over dx is simply this. So dy over dx is nx n minus 1. And let's come here and put our dy over dx, because 0 multiply this to give me 0. We're left with nx raised to power n, nx raised to power n minus 1 as our answer. That's the proof. So you can see that if y is equal to n raised to power x, dy over dx, by following the many steps, all the steps, dy over dx will give us n, x raised to power n minus 1. That's just the proof. So just go through it, see how you can practice, and then leave your concern in the comment section. I'll see you in the next video, guys. Thank you.